voltage dependent. That may be the one example I may have considered, and we will discuss about such problems. Now look at here. This is little more typical problem, and we have to be very careful. Calculation check करते रहना. थोड़ा भी अगर इधर उधर mistake हो जाता है, तो it becomes lengthy calculations. Is it right? Now, in this figure, how many nodes we have? I have made it simple. Already I have given this figure with marked nodes. This is A node, this is B node, this is C node, this is D node, and this is another node. Out of these nodes, we have taken this node as a reference node, whose potential is again 0 volt. इसको already ground node दिखाया है. 0 volt इसका potential. Now we will assume the separate current in separate branches. Now here I will assume this current as maybe the I1, this current may be the I2, this current, sorry, already I1 is given, yes. Anyone has a doubt? Yes, Suraksha. Suraksha का doubt है? Sorry?
Video pause झाला है.
Video stop झाला है?
हाँ.
Just wait. Astha? Chaya?
Yes sir.
Video stop झाला है?
नहीं.
No. Suraksha, it is a problem at your side. Okay, fine.
Yes sir.
Now here in this case, already I did little mistake here. Already this current is given, which is I1. That's why I will assume this as I2 in place of I1, because already this current is given I1. Is it right? Because this value is 6 into I1. This is I1. This is I2. I will assume this current as I3. Assume any random direction. This is the I4. This current will be the I5. This current will be the I6. This current will be the I7. And here, this current, already this is dependent current source. This current source is also given because it is the current source. Its value is given as it is I8. Now look at carefully. How many branches we have? We have 8 branches. 1, 2, 3, 4. Outer these 4 branches, and inner 1, 2, 3, 4. Inner 3 branches. So here in this case, we have the 8 branches, and how many nodes? We have the 5 nodes. 1, 2, 3, 4, and this is the 5. Now while solving such complicated problems, we have to be little careful. तो पहले हमें इस प्रॉब्लम को चेक करना है whether any branch has 0 resistance and still existence of the source is there. That I mean to say, whether we have to use supernode analysis, and I am expecting the answers from your side, whether the supernode analysis is required for this figure or not. Whether the supernode analysis is required for this figure or not. Yes. Avinash, Chaya, Madhuri, Rishikesh, Ruchira, Saurabh. Whether the supernode analysis is required for this figure or not. Yes or no? I will come back to you. When the supernode analysis is required, I will show some slides here, and then we will come back. Yeah. Yes. Someone has raised the hand. Yeah. Ruchira.
Yes sir, required.
Required. कसं सांगता येईल बाळा तुला?
Yes sir.
Yes. Tell me.
Sir, we assume middle node as a ground node, na?
Yes.
Then, here in the B, we don't have given resistance, na?
Okay, this is one branch which don't have the resistance. Yeah, as well as कारण 2 ब्रांचेस लागतील आपल्याला, कारण हे पोटेन्शियल वी आर एबल टू शिफ्ट दिस पोटेन्शियल. या एनीवन? इट इज यू आर क्लोज. यस Asta.
Sir, and in branch C, we only have that current source.
Where? Here.
In branch C.
In this branch. Or in
No,
this
sir.
branch. Yeah.
Yes,
in this
sir.
branch.
And in that.
Now look at. I will clarify some doubts to you, and because it is little more complicated, it is not that simple. When we have the current source, we don't have any issue. When we have the issue for the nodal analysis branch, we have the issue whenever there is the existence of the source with zero resistance. This is source with zero resistance. Now look at another branch. Look at this branch. This branch also, that is A to D, this branch also has a dependent source, and it is plus minus likha है इसके अंदर में, ये भी voltage source है. Means if any branch has a voltage source and zero resistance, ऐसे 2 branches होने चाहिए कम से कम, then we will apply this method, that is supernode analysis. In this case, supernode analysis is required. So here, this will be our supernode. This will be our supernode. Is it right? Now I will try to solve this particular problem. अगर इसको difficulty है, they can raise their hand. Is it right? Difficulty है तो hand raise करना है. Now first we will apply the KCL at this point and look at the difficulty. Look at the difficulty. If we are trying to apply here, in that case this will be one branch, this is another branch, this is third branch. But in this branch we are not able to calculate the current because potential difference divided by resistance, and its resistance is 0. That's why its value will be infinity. That's why its current will come as infinity. That's why what we have the another theory. Whenever its other potential of that particular branch is at 0, that is at ground, then in that case we can shift this potential to its nearest node. Right? The same thing. Shifting 8-volt source at node B. Are you getting me? We are able to shift maybe this potential or this potential. In this case, shifting of this potential is not possible because either this node or this node is not at the ground potential. Shifting का possible है जब उसका एक node ground potential पे चाहिए. In this case, already this ground node is given to us. That's why we are in a position to shift this potential only at the node B. That's why what we have, this VB is equal to 8 volt. This is equation number 1. How many equations we need here? At least we need the 4 equations because we have 5 nodes. This is ground node. This 1, 2, 3, 4. We need at least 4 equations. Is it right? Then we are not able to apply the KCL at this node because this is the source having 0 resistance. We are not in a position to apply the KCL at this node because again this branch is there. Means now we can apply the KCL at this node only, that is C node first. And then we will apply the KCL at the supernode. We will apply the KCL at supernode. Now here first, now try to understand me. Try to understand. यहाँ पे KCL हम apply नहीं कर सकते because ये zero resistance branch है, लेकिन इसका potential यहाँ पे shift किया, इसलिए equation हमें मिला. दूसरा, यहाँ पे KCL हम अप्लाई नहीं कर सकते क्योंकि ये ब्रांच है जिसमें जीरो रेजिस्टेंस है, वोल्टेज सोर्स भी है, वोल्टेज सोर्स है, जीरो रेजिस्टेंस है, उस केस में हम KCL अप्लाई नहीं कर सकते बिकॉज वी आर नॉट एबल टू कैलकुलेट द करंट ऑफ दैट पर्टिकुलर ब्रांच विच इज पोटेंशियल डिफरेंस डिवाइडेड बाय रेजिस्टेंस एंड रेजिस्टेंस विल बी जीरो. इसलिए ये ब्रांच जहां पे भी कनेक्ट होगा वहां पे हम KCL अप्लाई नहीं कर सकते. ये ब्रांच इस नोड पे कनेक्टेड है, यहाँ पे KCL नहीं अप्लाई होगा. यही ब्रांच इस नोड पे भी है, यहाँ पे भी KCL अप्लाई नहीं होगा. But we can apply the KCL at this node. First I will complete the simple part and then we will move to the complicated part. I will write here applying KCL at node C. At node C. We will apply the KCL at node C. How will be the KCL at this node? We don't have any issue when there is a current source with zero resistance branch. But we have the issue whenever we have the voltage source with zero resistance. Now I will apply the KCL at node C. If we are applying the KCL at node C, this is incoming, this is incoming, this is also incoming. This equation will be I1 plus I7 plus I6, which is equal to 0 because there is no outgoing current. Are you getting me? This current is the I1 incoming. This current is the I7, which is also incoming, and this current is the I6, which is also incoming. Now we will find out the value of I1. How is the value of this current? Value of this I1 current. That is, we have taken the direction downward. Means this is higher potential, this is lower. Means VB minus VC divided by 2. Means its equation will be VB minus VC divided by 2 is the I1 plus. I7 is the current in this branch. Is it right? I7 is the current in this branch. And how much is the value? Just wait. I have not written the value of that current. I will take from the book. Just a minute. I will copy that value. Because I have written the answer, it should match to the answer. इसलिए मैं उस value को just I will copy. Yes, that is 4 amperes. Is it right? I forgot to mention its value. Its value is 4 amperes. This is 4. This here, in this case, this I7 is 4 amperes. This is 4 plus I6. I6 is the current in this branch. It is downward. This is higher potential. This is lower. This equation will be, it is VD minus VC divided by its resistance, which is the 2. Simplify this equation and name this equation as equation number 2. If I am simplifying this equation, this will be VB divided by 2 minus it is VC divided by 2 plus 4 plus VD divided by 2, it is VD divided by 2 minus it is VC divided by 2, which is equal to 0. Here also, which is equal to 0. In this case, if we are separating the terms, then it will be VB divided by 2 minus VC, I will take it as common, then 1 by 2 plus it is 1 by 2. Is it right? That is VC plus it is VD divided by 2, which is equal to minus 4. And I guess this is equation number 2. Check the equation number 2. Sahi hai? Check the equation. Otherwise, I will take its value from your side. This will be 0.5 VB minus. This is 1 by 2.5 plus 0.5 is nothing but it is VC. This is equal to, plus, I guess it is 0.5 VD, which is equal to minus 4. This is equation number 2. Now check the equation number 2. Anyone? Avinash, Saurabh, Akash, yes. Unmute yourself.
Correct.
Now we have the equation number 2. Now here we have calculated equation at this node. यहाँ पे तो ये ग्राउंड नोड है और इन दोनों नोड्स पे हम नहीं निकाल सकते because the zero resistance branch is connected. That's why I will treat this node as a super node. This will be the super node. Now apply the KCL at super node. I will write here. Applying KCL at super node. Now look at whatever the shape I have drawn, to that shape, how many branches are touching? Applying KCL at super node. Try to understand the concept. इस नोड पे ये ब्रांच टच कर रहा है, ये कर रहा है, ये कर रहा है, ये कर रहा है. 4 branches are touching to the super node. Is it right? What are the 4 branches? This is incoming, I3 is incoming, I4 is outgoing. Means I will write incoming is equal to outgoing. This is which is I8 is incoming and I6 is outgoing. Means I guess this I3 is incoming plus I8 is incoming. Then I4 is outgoing plus I6 is also outgoing. This is the equation. I agree with this equation. Now look at, I will draw the shape. So this shape 1, 2, 3, 4. 4 branches are attached. Out of this 4, I3 is incoming, I4 is outgoing, this I8 is incoming, and the other value, which is nothing but this, is outgoing, which is the I6. This I6 is the outgoing. Is it right? Now here, try to find out the value of the potentials, that is I3, I8, I4 and I6. If we are finding the value of I3, where is the I3? I3 is the current in this branch. Is it right? How is the equation? VB minus VA divided by 2. It is VB minus VA divided by 2 plus I8. I8 is the current in this branch. Is it right? But this is the current source. And its value is 3 VC. Is it right? What is the VC? VC is the potential at the node C. That I will discuss later on. Which is equal to, ये जो dependent source है, इसका value कितना है? 3 VC है. That I have written. This is current. This is current. That's why its value will be 3 VC directly. Because it is dependent current source. I4. Where is the I4? I4 is the current in this branch. VA minus 0 divided by 2. That is VA divided by 2. Plus I6. I6 is the current in this branch. In this branch. How is the potential here? D. How is the potential here? C. It's VD minus VC divided by 2. That is VD minus VC divided by 2 is the equation. Simplify this equation. This will be VB divided by 2 minus it is VA divided by 2 plus it is 3 VC, which is equal to VA divided by 2 plus it is VD divided by 2 minus it is VC divided by 2. Simplify this equation. I will shift all these values to the left hand side. First, I will start with the VA. This is one VA and this is another. I will shift this value to the left hand side. That will become minus, and I will take minus VA as a common. Is it right? Minus VA as a common. Then it will be 1 by 2 plus it is 1 by 2. Then I will take the VB. This is plus. We have only one VB, and that is nothing but VB by 2. Then VC, we have here is VC and we have here is VC. That plus VC, I will take it as common. Then it will be 3 plus this value on the left hand side will become plus, which is 1 by 2. 3 plus 1 by 2. And that finally we have only one value for VD, and that value is available on the right hand side. On the left hand side, that value will become minus, which is minus VD by 2, which is equal to 0, and that is the equation number 3. We will simplify it later on, and we will name this equation as equation number 3. Is it right? If we are simplifying this, it is minus VA, I guess. Is it right? Because 1 by 2 plus 1 by 2 is 1. 1 into that minus means it is minus VA. Plus this 0.5, I guess it is VB. Plus this is 3 plus half means 3.5, I guess. It is 3.5 VC minus it is 1 by 2 means it is 0.5, that is VD, which is equal to 0, and I guess this is the equation number 3. Check the equation number 3rd for this figure. Check the equation number 3rd. Yes,
Sir, correct.
Correct. Now here we have 3 equations, but at least we have 4 nodes. 1, 2, 3, 4. Means we should have at least 4 equations. The 4th equation, how we will prepare? We will prepare from these 2 nodes, because we can find out VA in terms of VD or VD in terms of VA. I will find out from supernode. I will write here from supernode. What we will get from the supernode? I will find out VA, this value in terms of VD. You can find out VD in terms of VA also. If we are finding the VA, we have to start from VD. Yes, it is a VD. Negative to positive, that is a plus. This is the voltage source. 6 into I1. Are you getting me? Voltage source का potential find out करते हैं हम, current source का potential नहीं find out करते. Is it right? This is voltage source, that's a VD negative to positive plus 6 into I1, and this is the equation. Simplify this equation. Now equation will be VA minus VD then minus 6 into I1, which is equal to 0. This is the equation number 4. This is right. This is the equation number 4. Now we have 4 equations. This is right. We have the 4 equations. Yeah. But how many unknowns we have? Can anyone tell me how many unknowns we have? Yes. We have? Yes. Unmute yourself, Avinash. Or anyone other? Kone? Not able to see your screen right now. Suraksha.
Yes, sir.
How many unknowns we have? Avinash. Someone has raised the hand. Yes.
5, sir.
5. Absolutely fine. We have the 5 unknowns. Which are the 5 unknowns we have? We have the unknowns VA, VB, VC, VD, and last unknown is this I1. Is right. And if we have the 5 unknowns, how many equations we are expecting? At least 5. We are expecting at least 5 equations. But we have the 4. Now, the another equation can be obtained by calculating I1 in terms of VA, I1 in terms of VB, I1 in terms of VC, I1 in terms of VD, or IN in terms of combination of all. Now I will find out I1 directly. I1 is this current. Is it right? But we have what we have here. We have what we have. I1 is equal to, how much is I1? VB minus VC divided by 2. This is VB minus VC divided by 2. If I am simplifying the same equation, how will be simplification? If I am shifting this value to the next side, it is 2I1, which is equal to VB minus VC. Otherwise, VB minus VC, which minus 2 into I1, which is equal to 0, and this is equation number 5. This is VB minus VC. I am shifting this value to the next side, that is I1. But here, while putting the equations or while taking the equation sequence is important. How I have taken the sequence? I have taken the sequence. Equation में VB, VC, VD. Now look at this equation number 3. VA, VB, VC, VD. And if you have the current VA, VD, and I1. Means how is my equation? My equation is first unknown is always VA, second is VB, third is VC, fourth is VD, and finally the unknown is I1. This combination I have followed. Is it right? But our calculator does not support for 5 unknowns. What is the maximum capacity of your calculator? Our calculator can support up to 3 variables. But here we have the 5 variables. But anyhow, we have to minimize the number of equations. So एक तो equation directly आपका minimize हो जाएगा. This VB is already 8. Substitute that value of VB everywhere.